All right, here's number 13. A planet orbits a star with exactly the same mass as the sun. All right, so as soon as you see that, as soon as it says that, you can jump right to Kepler's third law. So let's write that out. A cubed is equal to p squared. All right, so it's as soon as you know that it's the same mass as the sun, you can use that. So A has to be, remember A, oops, so A, the proper units of A are called astronomical units, and the proper units of the period are years. All right. This planet is 0.74 AU from its star. That's actually very similar to where Venus is. Remember, we're one astronomical unit away from the sun. It's that the A is the average distance because planets get a little closer, a little further, but really not by much. Right? So that's what the average is. All right. So anyhow, we're going to use this equation because now, and we're going to solve for p. All right. So here, let's do that right away. So p is equal to, since it's squared, I'm going to take the square root of both sides, so it becomes the square root of a cubed, right? A cubed, and we know what a is here, so it's going to be the square root of 0.74. Right, that's already in the proper units, and I have to cube that. All right, so we'll get our answer here in just. So now it says, what is the period of this planet in days? So the answer is going to come out when we solve this initially. P is going to come out in years, right? So this is going to give us some number of years, all right? And then we'll divide it by or multiply by the number of days in a year, all right, to cancel. All right, so here, let's actually do this. All right, so here's our calculator. Let's clear that. All right, so all right, 0.74, and then you got to know how to raise your calculator raise something to the third power. So for this one, it's x to the y. You got to be familiar with your calculator. But by the way, if you ever just bring your calculator into my office during my office hours, I can always figure out how to do this. All right, anyhow, so there's 0.74 cubed, and then we take the square root of that. All right, and so it takes 0.6365 years. All right, so I'm just going to say 0.634. So 0.6, well, 6, I guess 64, right? Sorry, I didn't do that correctly. Here, let's round this. We don't need to round it right now anyway, but if we were to have it in years and it was 2 places past the decimal, it would be 0.64 years. All right. I mean, we have, I always tell people to wait until the very end to do the rounding. All right. So now, I just don't want to write, this entire number right here. So I just rounded it. And we know that in 1 year, there are 365.24 days. 24 days. All right. And so the years cancel. And so you just multiply the number that's in your calculator. Again, do it with the unrounded number and then round it at the very end. All right. So here it is. There's the unrounded number times 365.24. That's the number of days in a year. And so there is our answer. And so it tells us to round 1 place past the decimal. So it would be the number of days. So the number of days of the period here is 2. Let's get my calculator again. Just read it off the calculator. I mean, it's the same as the answer I got before. Because I didn't round anything, right? I didn't round until the end. All right, so this was, and that, by the way, that's when I did number 12, the last problem. It didn't come out quite the same because I I rounded the answer before I did the calculation, and I shouldn't have done that. All right, so anyhow, always round at the very end. So it's 232.5 days. All right, so that is number 13. Let's get to number 14. So number 14 is looks like another example of Kepler's third law. I mean, see that's the. Let me just say something about that right now. All right, so you read this problem, right? If let's say you didn't have the answer in front of you, an object is found in our solar system, right? Orbiting our sun. So that's the key thing. As soon as you see that, then you use Kepler's third law, right? All right. At any rate, so we know that a cubed is equal to p squared. All right. Now they gave us the period right here. The period is in days, so we're going to convert that, right? So this is kind of just the opposite of number 13. Well, not exactly opposite, but so it takes 1,332.7 days to go once around the sun. All right. Well, how many years is that? Well, we know that there are 365.24 days in 1 year, right? Because the days have to cancel. All right. So get my calculator, and we're going to do this one. So I can get it. Okay, there it is. And let's get rid of the last problem. All right, so 1,332 point. What is it? Point 0.7 times. Well, not times. It should have been. I'm going to just say times 1 because I should have hit divide, right? So divided by 365.24. All right, so this is going to be the number of years. All right, so it would take this object like 3.6 years, 3.65 years, something like that. So So we're not going to round it here. 3.65 years. I'm going to use the unrounded number in my calculator to do the final answer, right? So so it says like how far is this object from the sun? In how far is the object from the sun? So part A is just figuring it out, just using Kepler's third law. So the variable A is going to equal the cube root of 3.6. Again, I've got to leave this unrounded in my calculator, to get an exact answer. But I've got to square that. All right. So I'm going to square that, and then I'm going to take the cube root. Just to remind you, the cube root. So this would be taking 3.65, or again the unrounded number. You square that. That's a 2. Sorry. You square that. That doesn't look any better. I'm sorry. Let me fix that a little bit. That doesn't look like a 2 at all. All right. Hold on. All right. There we go. So 2. Square that, and then you raise that to the 1/3 power. Right. That's what it means to take the cube root. All right. So anyhow, here let's do that one. And there's my calculator. All right, so there's the period in years unrounded, and so I'm going to square that. All right, so that's squared, and then now I have to raise that to the 1/3 power. So I click on this. Now remember, my little trick for this is you got to use 1/3 is a repeating decimal, so you got to use parentheses to make it raised to exactly the 1/3. So parentheses 1 divided by 3, close parentheses. And now some of your some calculators that people have will already have a cube root button in it, and so that solves that problem. But if you don't have a cube root button, you can use this 1/3 method. All right, and so that tells us the distance. So it's so let's see. I guess they tell us to round 2 places past the decimal. So this is going to be 2.37. So part A is 2.37 astronomical units. Remember, you only put in the numbers when you do this. The test part B in Blackboard. Okay, you just put the number. It's already asking you what the unit. It already assumes that you know what the unit is. All right. So and then part B, you just have to know how many kilometers are in 1 astronomical unit. All right. So we're going to take this number 2.37. That's the rounded version. I'm going to use the unrounded version that's in my calculator, and I just know that in 1 AU there are one. It's 150 million, or you could write it this way: 1.5 times 10 to the eighth kilometers. That's just a quicker way of writing that. All right, and so the AU's cancel, and so you just multiply by the unrounded thing. Where's my calculator? Okay, right there. All right, so that's the unrounded version, and then I'm going to multiply times. You could say 150 times 10 to the sixth, or 1.5 times 10 to the eighth, which is the same thing, right? All right, and so now we're going to round it. To two. So you can see, it's a rather large number, 355 million, right? Because the decimal point is right here between the 4 and the 7, and so I'm going to round it. I'm going to put it in scientific notation, and why didn't this come out to be the same? Yeah, it is. It is the same. Okay, so it's 3.55, and notice that there's another 5 after that. So if we round it, all right. So this becomes 3.55, but there's another 5. So I round that second 5 to a 6, and it's of course times 10 to the eighth. All right, kilometers. All right, so that is part B of number 14. All right, and so here let's look at this one more time. So the decimal point is right here. That's 1, 2, 3, and then 1, 2, 3, and then 1, 2. Right, so times 10 to the eighth. I just wanted to. So you can always prove that to yourself, by the way, by just saying divided by 1 times 10 to the eighth. And that should give me 3.555. Right? So there it is, 3.555. All right. That's it for this one. I'll have to do the next one in the next video. Oops.